Hi, my name is Nils Wandel, and in this video I want to provide you with some additional details for our work on Harmonic Inharmonicity, eliminating beats with quantized harmonics. Before we start, I want to recommend you to use high quality speakers at a moderate volume level to get the best listening experience. This video is structured as follows. First, I want to briefly explain the problem with beats in equal temperament. Then I want to show you how we quantize the harmonics in order to prevent these beats. Then I want to quickly mention how nonlinear filters can hamper the effect of quantized harmonics. So this is the reason why you should use high quality headphones. And finally, I want to show you some practical examples how quantized harmonics can effectively prevent beats by comparing some chords with natural and quantized harmonics. So beats appear if two signals with similar frequencies interfere with each other. And if we have, for example, two sine curves as shown here on the top with similar frequencies, and add these two signals up, then we get these undulate modulations of the volume, which is what we call beats. Now, if we play a certain tone, it usually doesn't consist only of one single frequency, but rather one single frequency for the so-called fundamental, plus integer multiples of that frequency, which we call harmonics. So if we want to play multiple tones together and if we want to avoid beats, then we have to take care that similar frequencies in the harmonics match perfectly. And if we want to play, for example, a just fifth, then the ratio is 3/2. So this means that every third harmonic of the lower tone matches perfectly with every second harmonic of the upper tone. Unfortunately, it is mathematically impossible to design a scale that contains only just intervals. Either we get a few just intervals, but also some intervals which deviate heavily from just intonation and thus expose a lot of beats, such as, for example, the whole fifth, or we spread the deviations from just intonation equally among all intervals and obtain equal temperament, as shown here in the center, which results in slight beats in all intervals. Now let's listen to the different intonations and see if you can hear the beats in equal temperament and in the whole fifth. Today, most synthesizers and digital audio workstations are based on equal temperament, so let's have a closer look. As you can hear, beats are basically present in all the intervals due to the equal temperament, and by using an equalizer we can make these beats even more noticeable. That's why we propose a novel method that avoids beats in equal temperament by quantizing the harmonics. If we shift the natural harmonics, here shown on the left, to their closest matching semitones on an equal tempered scale, then no matter the interval, the harmonics will always remain on the same subset of equal semitones. Therefore, in an interval, the harmonics will either match perfectly or they will be separated by at least one semitone. And this results in a great reduction of beats. But before we start listening to examples of quantized harmonics in intervals and chords in polyphonic music, let's first hear how the sound of quantized harmonics compares to natural harmonics for a single tone. Since we only used 12 quantization steps in this example, the shifts in the natural harmonics can be quite substantial. So we also tried out higher numbers of quantization steps such as 24, 36 and 48. Have a look. We did not go beyond 48 quantization steps because in that case the steps would become so small that beats could reappear in between individual quantization steps. If you heard a very strong difference in the last example, or if you heard beats in the quantized harmonics, then this might be because you used a low quality speaker or because you saturated your speaker by turning up the volume too high. Let me show you what I mean in the DAW. If we oversaturate our speakers, we obtain a nonlinear response curve, and this can introduce new natural harmonics into the sound that might interfere with our quantized harmonics. So we always have to make sure to quantize the harmonics only after all the nonlinear filters were applied, and to use good speakers to avoid these detrimental effects. Linear filters, however, like for example reverb or equalizers, are completely unproblematic. Finally, let's see how beats can be avoided through quantized harmonics in equal-tempered polyphonic music. The following example contains 3 times the same cadence, first in just intonation with natural harmonics, which unfortunately causes problems with keyboard instruments. Second, in equal temperament with natural harmonics, which exposes quite a few beats. And third, in equal temperament with quantized harmonics, which basically eliminates all the beats. Now let's see how natural harmonics and quantized harmonics compare in a DAW that is based on equal temperament. As you can hear, quantized harmonics really eliminate basically all of the beats and thus result in a much more even timbre. Thanks a lot for your attention.